So let us look at the code that actually changes the state of the process or of the task. And you can see here that there is set current state that basically changes the state of the current running process using the different the different flags that that we have mentioned, and one of them is, for example, task and interruptible, and it basically goes to the current state, the current task state. So it basically puts in the current task, change the state of the current task to the state that it actually thinks it was called to change it with. And these flags are actually also defined. If you just go on the code and just press F3 on, for example, task and interruptible, or do a search on these flags, you'll find them defined in sequence. So there are multiple of these flags that are defined. And there is also a set task state. So this was set current state, and that's basically for the current task. But there is also a set task state, which is for another task, which takes task the task that you are trying to change the value for or the state of for that task as input, and the state value. Okay, so these are basically the ways that the states are changed in the kernel. So the process tree is a concept in Linux where you basically have all the processes as descendant from the init process. We have actually mentioned that in the class, that we have the init process, the father/mother of all processes that runs on Linux, and init always has a PID of 1. Okay, and this is basically the process that the kernel, when the kernel loads and starts, this is the very first process that starts. And the relationship between the processes is stored in the process descriptor, which is in the task struct. And each task struct has some fields to basically say what is the parent of this task, but also what are the children of this task. So this is actually the code from the task struct that basically shows you where's the parent and where are the children and siblings, which are basically that siblings, that they are on the same process. They're on the same level when it comes to when they were forked, basically. And also some other things that you might need, such as who's the group leader of these tasks. But in general, you can actually go through the whole process tree by just looking at your own process, right? Because basically, if you iterate until you reach the topmost process, then you can actually reach init, and from init, if you look at all the descendants of that process, then you can see all the descendants in the Linux system, because init will have all the other tasks that got spawned afterwards as descendants of init, and basically in a tree. And you can basically use this call to get the parent of your current process, of your current thread. And you can use basically also this to go through the children of your process. Yep. So this is basically the code you would need to basically go through the children of the current process that is running. So that means you can iterate from the top to the bottom. And to get to init, it's actually quite simple. You basically have the task struct that you're looking at, and the task, and you pick the current task, and as long as the task is not equal to init task, it's not equal to 1, basically, go to the parent, and then in the for loop you don't really need to do anything, because the for loop will just go all over until it basically reaches the parent. Of course, you can print, or you can use print key to print whatever task you're on. You can do stuff inside, but to get to the init process, this is all you need, basically. So a question arises. It's actually very simple code to implement, and I advise you to try it. And that's how do you print all PIDs using just the task struct of your process. I mean, that's not something that I want you to do for an assignment or anything, but it's actually fun to take a look at things in that way and basically do things with your own hand.